Hello, I'd like to welcome everyone to the Center of Excellence in Smart Construction virtual seminar. How the 3M's, material, machine, and money are affecting the progress of 3D printing in the construction industry. My name is Wendu Oguda. I'm the Center Manager for the Center. Please note, we're recording this webinar and all lines are muted. If you need help at any time, please send us a message via the Q&A chat box. Today's event will last up to 60 minutes. We encourage you to ask questions throughout the webinar. Simply type them into the Q&A chat box in the lower center of the screen and be sure to click the send button. The Center of Excellence in Smart Construction is committed to advancing industry-led innovations in the built environment that will revolutionize the way we develop, manage, and operate smarter cities. The Center partners with like-minded organizations and government entities to lead the transformation of the built environment and development of next-generation professionals for the benefit of the economy. The Center is a global hub for disruptive thinking, a platform for collaborative research, and a model for solutions development, stakeholder engagement. The Center's industry-led research and development has a focus on enabling technologies around three main research themes: performance and productivity, sustainability, and well-being. The collaboration is intended to provide leadership in the future direction of the industry that will inform policy decision makers. We would like to acknowledge our industry partners who have been integral to the development of the Center and their engagement with industry. We would also like to acknowledge our industry affiliates who have been engaging with us on some very exciting projects. It's now my pleasure to introduce our esteemed industry and academic experts. Kyle Kral is Senior Principal and Dubai Office Director at Thornton Tomasetti. He oversees all practices in the Middle East, and he has a depth of experience in structural design of commercial, sports, residential, and mixed-use building. Some of his notable projects include Hazard bin Zayed Stadium, the New York Times Building, and Galleria Mall. Chris is the Regional Directional Lead for Mott MacDonald. He's a chartered member of the Institution of Civil Engineers and is currently the digital lead for Mott MacDonald's Region and Global Delivery Services Unit, as well as a leading member of their wider global digital leadership team. George is Associate Professor in Structural Engineering at Herotort University. He leads a research group that conducts research in sustainable and resilient infrastructure with emphasis in steel and steel concrete composite structure. He holds a PhD from the Polytechnic School of Milan and has served as a postdoctoral researcher at the West Sydney University. He's recently been awarded the Leverhulme Trust Royal Academy of Engineering Research Fellowship to explore the feasibility of metal 3D printing in large steel construction. Paul Mollett is the Group Engineering and Technology Director at Robert Bird. His role is to drive forward and sustain the relentless pursuit of engineering excellence through the strategic application of transformative technologies, the identification and adoption of value-added innovation, and the development of staff skills necessary for the future of engineering across the global business. Yasser is the CEO of B3 Engineering Services. He's established the construction industry with state-of-the-art disruptive technologies and innovative ideas to help building smartly. With more than 36 years experience in specialized construction methodologies, off-site manufacturing, and design for manufacturing, taught with modular construction, Yasser has participated in bringing many landmarks in UAE to reality. I'll now hand over to Kyle, our moderator for this evening's webinar. Thank you.
Thank you very much, Wendu. Just some words on 3D printing and where we're headed, how we got here. You know, three-dimensional printing of structures is relatively new. For those of you who are joining us from the UAE, you probably have heard a couple of years ago, 2015, when Dubai announced that by 2030, they wanted 25% of all construction to be 3D printed. That's a huge ask for technology that's just starting to evolve. There are a lot of questions about the technology and the benefits that it can bring: speed, accuracy, reduction of labor costs, reduction in waste, and enhanced safety and other aspects of what 3D printing can do for us. But obviously, since it's brand new, there's a lot of questions that are being raised on, on scalability, testing, and standards, which are all really being investigated now through academia and also through industry leaders. Dr. George is going to be giving us about a 10-minute presentation. Afterwards, our panel, who really have some really great experience in 3D printing in the region, will opine on various aspects from the presentation. And then we want to very quickly turn it over to questions and answers. So as the presentation is going on, and certainly during the panel discussion, please make use of the Q&A box. Let's get some questions going, and we will then focus about 15 or 20 minutes after the panel discussion on getting answers back to you. This time, I turn it over to Dr. George for his presentation.
Thank you, Kyle. I will share my presentation now. Right, can you all see the presentation?
Yes.
Okay, so thank you very much again. My name is George Vastravelis. I'm associate professor here at University in Edinburgh, and I'll try to provide here an outlook on the current state, let's say, in research mainly and in construction of 3D printing. Just to emphasize that I will be focusing on metal 3D printing, but in the discussion we can also cover 3D printing of concrete. So the topics that I will try to discuss are first, I try to give a brief description of the 3D printing techniques and capabilities that are relevant specifically to construction, and some recent examples of how these are employed to realize some components in mainly steel construction. Then I will try to summarize the major challenges in terms again of cost, this money, material, and machine capabilities. Finally, the opportunities that 3D printing gives us. Kyle already mentioned most of them, but yeah, I'll try to put them also in terms of future infrastructure, if you like, vision. Some current research projects and what people are doing around the world, and then discussion. Of course, in 10 minutes, I cannot cover in great depth all of these topics, and so there will be some open questions for discussion afterwards. So let's start with 3D printing techniques that are relevant to construction. So there are two main techniques. One is the powder bed fusion, PBF, and the second is the directed energy deposition, or DED. So powder bed fusion creates objects in a layer by layer approach. So objects are built up with individual layers that are very, very thin. So in the order of tens of microns thick. And this technique offers the advantages of geometric accuracy, the surface roughness is typically less than 20 micrometers, so very smooth surface of the component that is 3D printed. And essentially, there is virtually limitless complexity in geometry. So we can 3D print metal parts that are as complex as we like. Okay, there is no limit in the complexity. The disadvantage, there are two major disadvantages using this technique. One is that the build times can be very long, taking tens of hours or even days. The melting rate is roughly 50 grams per hour. And the other major disadvantage is that the size is limited by the chamber that is used in the machine, 3D machine, which currently is approximately 250 millimeter by 250 by 250, so a cube. I think there are some, recently there are some machines developed that allow up to 500. But again, there is a limit in the size, okay. Therefore, this technique is suitable for smaller parts that require geometrical complexity. And this is an example of PBF in action. So there's a powder bed fused built up 3D built square hollow section. And this is the final product. An example, a very representative example, one of the first actually applications of this technique in construction was done by Arab. This is an image taken from their website. So they use this technique to, and specifically the power bed fusion to 3D print the nodes of tensegrity structure that was designed and built in The Hague. So this structure involved 1,600 nodes, each requiring a unique design, and therefore optimization and customization from 3D printing was an option. So on the left here, we see the conventionally manufactured node. Okay, so using the conventional, the traditional manufacturing, if you like, we use, try to use the subtractive technique. So we have, this is, I think that this, I believe the manufacturer of this node would start with a solid cylinder, then extracting material to make it a tube, and then welding a number of plates in the circumferential, let's say circumferentially to have the slots to connect the cables, for example, of the structure. So if we use this technique, if we use this technique, then most probably the same joint would be used for each of the 1,600 nodes. So the first iteration to optimize this node is here in the middle. That's the first iteration. The final node, the most optimized, if you like, is this one here. So this was all 3D printed by the powder bed fusion technique, and this resulted in a 70% weight reduction of the node, and overall in 40% weight of the final structure reduction. Yes, and that was one of the first projects. Of course, this took a lot of time to print it, and also some significant post processing. And I don't have any information on the actual cost of this with respect to the traditional manufacture. So that was the power bed fusion. Then the second technique is the direct energy deposition. In this technique, metallic powder or wire is being fed directly into the focal point of a laser or electron beam or plasma arc, resulting in a molten pool that can be selectively deposited. And there are two options here: the powder-based DED, which has the same disadvantage as PBF, so it's not worth mentioning. The one that is promising is the WAM, so the wire and arc additive manufacturing, which is a DED technique that uses arc welding tools and wire to build up a component with the final object formed entirely from the deposited weld material. As an example, this image is from MX3D. So MX3D is a Dutch company that I believe is the first company that applied this technique, the WAM. They use this technique to 3D build large-scale parts for construction and other industries. So here is a robotic arm that essentially 3D prints this node here, an optimized node. So the advantage of WAM is that it is a technique that's suitable for medium to large-scale parts with low to medium geometric complexity. with this technique, we cannot have very, very complex parts, but it's okay to have low to medium geometric complexity. It allows for higher deposition rates as compared to PBF. So currently it's 49 kilograms per hour. Okay, this as opposed versus 50 grams per hour for the PBF. We can 3D print virtually unlimited part sizes because it doesn't require a closed environment. It doesn't require chambers. It's, virtually we can 3D print any part size. And it's much cheaper than the power-based techniques. So the base material for the WAM is an order of magnitude cheaper than the powder used for the. The disadvantages are first, the final product, the surface is quite rough. So the roughness is more than 0.5 millimeter, even more, or 1, 2, or 3 millimeters rough. So the final part may need treatment. So further processing to make it smooth. And I would say the most important disadvantage is that due to the heating, due to the technique that is used, that inputs heating, we have high residual stresses and distortion in the final part. And therefore, all this should be, of course, taken into account in the design. Therefore, this technique is suitable for bigger parts that require medium geometrical complexity. And this is an example. I think you are all came across in the news of the first 3D printed bridge from MX3D in Amsterdam that is all built using the WAM technique. And that's an optimized node, again from MX3D for a project in Japan. Now, major challenges, I would say, in terms of money, of course, is the cost and the long time. Of course, so current price of 3D printed steel part is multiple times higher than a traditional manufactured one. Just an example, I took some quotations for a 3D printed, potentially 3D printed optimized shear connector for steel concrete composite bridges and buildings. The price I got from various companies range from 400 pounds to 2,000 pounds per unit. I compare while the conventional one costs about 80, 100 pounds per unit. This is a stainless steel, duplex stainless steel optimized shear connector. We can see here we have great variability in the price. So I took 400, 500, 600, then up to 2,000. Reason, I don't know the reason, possibly it's the location of the country. Just one thing to emphasize here that is duplex stainless steel. So because when we 3D print steel, it doesn't make too much difference if we print carbon steel or duplex stainless steel. It makes sense to 3D print stainless steel, yeah, duplex stainless steel, because more, of course, it has many well-established advantages. Yeah, the other challenge, printing times, especially for powder-based fusion techniques. These are related to machine capability and the technology. So it is expected that advances in technology perhaps will improve the lead times. However, currently it sounds unrealistic to 3D print steel beams or carbons at reasonable cost. In addition, yeah, significant post-processing may be needed that should be added in the final time, either computational or to 3D surface roughness. 3D printed circular hollow sections, and you can see the roughness in the surface using the WAM techniques. Okay, that's it. From Laghi et al. In 2020. Number 3 is the material. So the second M, the material. We don't know too much of the material yet. So far, there are some stress-strain relationships established for selected steel grades. Of course, much more work needs to be done because we don't know, for example, the fracture parameters of 3D printed steel, which are relevant to applications that, for example, seismic energy dissipating devices that fracture is critical, or other devices. We know that there is orthotropic behavior, so the stress-strain response depends on the direction with respect to the direction of the printing. So usually researchers take coupons from that are parallel to the direction of the printing, 90 degrees and 45 degrees to the direction of the printing. And the behavior is is somewhat different. So again, how to implement this orthotropic behavior and what exactly will be the final constitutive law that will be used, for example, in finite element analysis packages remains a bit of an open question. Again, in terms of materials, but we move now to components. Again, in terms of component behavior, we have very limited experimental data. For example, the two works that I know so far, that I've done so far, are this one that's done in 2019, and they tested 3D printed tubes using the power bed fusion technique. The failure modes here are, let's say, quite expected. However, in this work here, you can see that the failure modes are a bit unusual. So especially the third figure here with this rupture, I would put a question mark because it's not very usual in conventional steel. So, I mean, a lot to be done here in terms of components, again, in terms of component level behavior. Finally, another challenge is the standardization and certification of components to allow mass production or mass customization, if you like, and widespread application. So standards should include some specification for 3D printed steel. Sufficient amount of data and standardized processes are needed. There is a big European, multi-million European project currently in the Grade that aims exactly to accomplish this, to develop robust methodologies to ensure manufacturability, reliability, and quality of a 3D printed metal component. Opportunities and current projects and how I see the vision for future. Yeah, I think that currently, as I already said, it's unrealistic to have girders or beams tailor-made and 3D printed. It's in terms of cost and in terms of time. However, it seems promising in the current situation to have hybrid solutions. So hybrid construction, for example, to 3D print critical parts such as the nodes or other, for example, sacrificial elements for resilience, for example, that will be 3D printed, and then bigger parts like beams and columns will be traditionally manufactured. Current project is the 3D printed steel nodes for sustainable and resilient infrastructure. So we have steel nodes that are optimized, and they have some tailor-made slots to connect the beams in the two axes via some, again, optimized pins and sacrificial fuses. The objectives, the desirable objectives, will be to have, again, satisfactory performance, of course, under gravity load, but also to enhance the robustness and the sustainability in steel structures with nominally pinned joints. And other benefits will be that we eliminate the waste, we don't have over-designed nodes, so everything is tailor-made, unique designs for every node, plug-and-play construction, and deconstruction and reuse, in line of the modern circular economy model. Conceptually, it looks like that. So we have the optimized node. This is just conceptual, but we remove the material from where we don't need it. We just leave only the necessary material. At the same time, we can create some slots here to connect the beams, and we can use also some optimized fuses. And currently, this is a very recent project that was presented at the conference this month, actually, in Eurosteel. That's by some researchers in Germany. So what they propose, they say why to use end plates, for example, which, for example, the central part is not used too much. We don't need the central part. So let's take this tab and try to optimize and also create some 3D printed details to just connect the bolts through the flanges of the column. And so they propose this as a first step to save material. So the idea is the column will have this protruding 3D printed slots, or the beam, actually. In this case, the beam will have these 3D printed details already printed using the robotic arm and the WAM in the shop, and then you assemble this in the factory. Okay, that's all. I think I took 4 more minutes. Thank you, and yeah, let's have an interesting discussion.
Thank you, George. That was really informative. I would like to now just open it up to panel discussion. If all the panelists want to unmute, and maybe we can start with you, Paul, and work around the rest.
Well, thanks, Kyle. And well, firstly, thanks to George for a fascinating presentation. We see a lot of focus on the cementitious applications of additive manufacturing in construction. So I think it's really good to see something about metals for once. So thank you very much, George. I'm sure we're going to see some great questions coming through. Yeah, but I just wanted to mention a few high-level thoughts on the potential adoption of 3D printing in the industry. And I think we can all see from your presentation and for the things we see on the internet, that there's advances in a technology and a proof of concepts that we're seeing. And the question really is the industry needs to ask itself is, what's the problem we're trying to fix? Where's the value in the adoption of the technology? And how can its value be realized? So, we see many case studies and examples, but evidence of true added value is quite hard to find. And that's not to say it doesn't exist or that it won't in the future, but we need to start getting a clearer picture of these holistic benefits. One of the key challenges, is scalability. Most of these case studies are small single projects, and the economic and logistical and practical risks and opportunities are quite hard to identify and then extrapolate from. And a further reason is the fragmentation of our industry and the project-based supply chain way of procurement that we have in our industry. And I think we'll only realize the true value of 3D printing when it engages that whole supply chain, including design, at the appropriate time. And for a new innovative technology like 3D printing, much of the development work and supply chain engagement can't be funded or implemented on a project basis. So we need to review our risk and reward mechanisms to encourage more collaboration. And this starts to lead into a wider discussion on how our industry tackles innovation. And in many respects, I think 3D printing represents a perfect case study opportunity on how we need to change some of the fundamentals in our industry to drive greater innovation. I'll leave it there for now. I'm sure other people have got many other things to say.
Sure.
Great presentation. Thanks, George.
Chris, do you want to add to that?
I think Paul's hit a lot of the key points, but I think the thing I would like to raise is that we go back to the introductions when Wendy was showing where the Centre of Excellence of Smart Construction fits into this. This is a role that academia has in developing this, because those of us that are involved in the delivery of live projects, as Paul mentioned, there's a risk there that we can't take. I mean, we are liable for our designs, we're liable for our constructions, and we just don't know enough yet about the long-term performance behaviours and so on to be able to make that decision as to whether we implement it. So this is where academia can come in and do the testing on 3D printed materials, run the studies, produce the literature for us to read, to understand if this can be a feasible replacement for elements of the construction process. I think there's a lot of technologies around there, including 3D printing at the moment, that have the potential to seriously disrupt and change the way that we work. And I think the next 3 to 5 years are going to be absolutely crucial to that, because we do need to see where these emerging technologies could lead us. What are the benefits to society as a whole, to the clients that we work for, and what problems will they solve, and will they be cost effective, both in the short term in terms of the capex cost, but more importantly in the long term operations and maintenance costs as well.
Very good. Mohammed, would you like to say a few things?
Yes, first of all, thank you, George, for the very interesting subject. And for me, this is the first occasion where I know got to know some real implementation of 3D printing in metallurgic work. I've heard about it, but I haven't got the chance to get to know this in such deep details. Thank you for it. And actually, this brought to mind a couple of questions, because I can feel that maybe despite the feeling that it is too far, but I believe, especially in metal 3D printing, there are opportunities to contribute to the construction industry. But to do that, we have to understand from a material point of view the long-term performance of the printing material from durability and corrosion concerns, especially when we use it in construction. And that comes to the implementation. Where can I implement? Where can I use it? And the idea came from your example about how to connect the beam to the column and printing those cleats. Actually, precast industry and now the trend of modular construction in the world, there are a lot of such implementation, such application of 3D printing in metallic applications that can be used to generate the difficult connection details that generally take a lot of manpower to manufacture them out of welding and being concerned about welds. However, once we resolve the concern of durability of those weld points based on the new techniques that we have, I think there is a lot of implementation to get it. The challenge would be, when will be the point of time that we can see cost-efficient implementation of 3D printing, especially in metallurgy? And I believe this is what you started with, and the difference in prices between the conventional implementation and the 3D printing application is quite large. It's minimum 5 times and aggressively going to 20 times. So big wide range, and we need to resolve that. I believe through, as Chris mentioned, through academia, through researchers, through trials, there is a lot of opportunities that we can resolve it. Hopefully we can see it before our hair gets more whiter.
I may not have that much time left. Just building a little bit on what Chris and Paul said, I do believe that, it's a challenging time right now, and academia does have a role in advancing these prototypes, and it's fantastic to see her at Watt, pushing forward with this and growing this industry. I think one of the biggest challenges that most people have is when someone starts talking about 3D printing is, they want to 3D print everything now. So somebody expects we're going to put a 3D concrete printer in the middle of the desert and print the next Burj Khalifa. But 3D printing really does have, I think, a future, and you need to figure out what parts you're going to print and what parts we're going to build conventionally, because certain types of conventional construction are very good at what they do right now with precasting and structural steel. Standard shapes are fine for what they do, and we really shouldn't be trying to replace precast concrete plank with a 3D printed plank. But the 3D printed aspects give us a lot of flexibility for future design, unique design, one-off design, and also printing that can go around the clock. I don't know, I will let anyone else have a follow-up, and then we can get into questions and answers.
I think there's some great comments there. I think we have to think of 3D printing not as one technology or one tool, but as a suite of tools that can be applied in different ways. Our methods and processes over the centuries, and literally centuries, have developed through experience with both concrete and steel, and we build in a certain way with concrete and steel for good reason. We've been able to identify how we can do things on site and off site with these materials. We need to go through the same process with 3D printing. Essentially, we need to understand the materials that are available to us and how that kit of parts fits with the wider kit of parts we have in our industry. And I think by going through that exercise, we'll start to pick up where the real value is.
Yeah.
I believe what Kyle has just mentioned is really interesting, and this is something we have discussed in several occasions in other seminars. Rather than going and printing the whole building, let's think of components of the building. And printing steel components in the construction industry is a good option as well. It's a good approach. Rather than going to the large scale, as Paul mentioned, we need to learn a lot. The material is still immature, I believe. Our knowledge is not that much, let's say, developed yet. The techniques need to be enhanced. And until we reach to that point, we need to just calm down and focus on components rather than going with haste and thinking of building buildings. And I heard about multi-story buildings being 3D printed. Here comes to another dimension. What about 3D printing in concrete? And this is the big dilemma now. We are, especially in the Gulf area, to print any component or any building, we are building a tent around that site and trying to control the environment of that site to do to print a house or print a wall or print a building. Nobody is thinking of what is the cost of that, what is the time needed for that, and what is the cost, the advantage if I do that. Rather than thinking going that far, my recommendation has always been think modular, think offsite, and reduce the volume of the component that you're talking about. That makes it more achievable, more easy, until the technology grows a bit further. And maybe Chris mentioned as well, it could not be so far. It could be 3 or 4 years. We don't know. Development is going faster nowadays with the technology development. And I believe this is the message to all our colleagues in the industry.
That's something. Yes, I mean, currently there is a study which shows that currently the average utilization ratio in steel building is 50%. So essentially, we use double the material that we use, and this is due to the automation design and the repetition of the design. So we use the same beam. So it would be good to have optimal bespoke, let's say, geometries for beams. Also, it would be good to have, for example, closed section for columns with internal stiffeners 3D printed to avoid local buckling and to avoid concrete infill. However, I believe this is not possible now. Perhaps this will be possible in 10 years, I don't know, 5, 10, 15, 20 years, I don't know. So it makes sense now, yes, to, as all of you have actually said, that to currently to focus 3D printing specific parts, and it makes more sense, for example, to print the most critical parts that perhaps there we can have not only a benefit, not only in terms of material, but also in terms of structural behavior and safety. For example, in seismic areas, when we have the moment connections, use a lot of stiffeners, a lot of bolts, haunches, welds, etc. This is a huge material. Also, the modern trends need in seismic engineering require what? Low damage and damage at a repairable level after an earthquake. So, energy dissipating devices, self-centering, again, self-centering materials would all make sense and perhaps would result not only in material saving, but also essentially in safety and resilience and sustainability of the building.
And I think.
Go ahead, Chris.
Yeah, so I think the other thing around this as well, you know, it's components. You know, we shouldn't be looking at whole systems.
Yes.
I think the bit that really jumped out, which I think we didn't quite, or was potentially overlooked in George's presentation, was the biophilic nature of design, because you know we've got the opportunity to study how nature does things. We have the technologies in digital design. We can take a leaf out of the manufacturing industries approach into how they look at the stresses and the strains and the impact on these materials and these shapes, so that we can minimize the amount of material that we use. So, you know, I think that it creates a lot of opportunities, but I think we do have to start small. We can't be, you know, building replicas of the Burj Khalifa out of 3D printing material yet. But I think that, you know, while I would advocate components as the immediate way forward, I mean, one of the other ways forward could be around simple units that are for housing or so on. I mean, you know, there are still diasporas across the region and refugees, etc. And, you know, so there are simple ways where this could be a cheap and cost-effective way of providing shelter for those that are in most need of it. And yes, I appreciate Yasser's comment around, you know, having to build a tent to protect it from the elements. But, you know, if these things are small, you know, and we've got a way to set it up quickly, then, you know, this could be an option for that. But that really depends on the use cases that we find for this material. And I think that at the moment, what we have in front of us is a very exciting technology, but we don't know how to use it best yet.
Yes.
I think just to get on to some of the questions, but you know, obviously the question is raised: do we print on site or do we print in a factory and ship it to the site? And you know, concrete is probably better suited for printing on site, where structural steel, the steel printing that George showed in his presentation is probably only suited for printing in a controlled environment. There are a couple of questions that came up. One is, what is the sustainability and energy savings opportunities offered by 3D printing? And I did see a presentation by the AISC earlier this year on the 3D printed bridge that you showed. And the question that was raised, and I'll throw this to George, is, you know, you've taken energy to make the weld material, or the material that goes into the welding that gets deposited. So you've made it with energy. You're now using energy to create the welded product, but you're saving material in the long run. Where does that balance?
I personally think this idea of saving material through 3D printing, through techniques such as topology optimization and so on, I think that's premature. I think our understanding of the materials and scalability just isn't there yet for it to even be on the radar, to be honest. I think the sustainability benefits are probably more subtle. And just picking up on something Chris said, you know, if you look at what ICON are doing, ICON from Texas, and what they're doing with sustainable housing and low-cost housing, you know, in principle, if we can develop some of the techniques around 3D printing materials and being able to use local materials with a 3D printer, you can envisage a situation where you could rock up to a site in the third world or in a developing country with a 3D printer on the back of the truck. If you've got supply to water, you bring a bit of cement and you've got some local material, you can build people houses in a way that's far more sustainable than anything that could have been done before. So I think we need to look at it holistically and in the round, rather than thinking about what's the most efficient structure just yet.
Yes, or printing on Mars.
Yes.
One of the other questions that was raised is on testing, inspection, and quality control, and especially from, you know, I think from the concrete side, we know concrete, you know, 3D printing concrete is not very different from casting concrete, but from the steel standpoint, you know, how do you guarantee quality control? I think Mohammed raised that question before.
Yes, concrete has always been the victim of bad practices somehow, and there is always a concern of consistency of quality, and with all the development that we had, we still see a lot of deviations from the let's say designed parameters. That's why we created the tolerances ranges to overcome those problems. This is more critical with 3D printing because the material, we as let's say as human being developing this now, we are still learning, because let's talk about our experience. Few years ago when we started doing 3D printing, although we were printing in a controlled environment. The material that worked with us in March, we found that it is not stable after a few months, and we changed the grout configuration with the supplier. Then whatever worked with us on October, it didn't work afterwards in February. So we went through trials and errors until we reach. Now imagine what will be the situation when we are at site and we are surrounded with changing environment, and we can expect a lot of deviations. That's why it is really a concern. There are researches around that, and I've seen a research done by Eindhoven University a couple of years ago about a testing regime of 3D printed grouting, and it is going on now. They are doing the trials further and further, and I believe very soon we might. Of course, there are other trials all around the world, and there are some literatures about it. But I believe as industry, we still need some more time to get those fixed, like what we know about concrete, the normal concrete that we are using today. Still, it is kind of a new material. It has a lot of variables, and surrounded with a lot of variables, we need to address them all. It's not only the material, the question about meeting the criteria or maintaining the quality. It's the question about how this material will work in time. It's still too fresh material, not tested really for more than 10 years to know what will happen in future. Still, we don't know. And a lot of researches with academia are to be done here.
Another question that came in that I'll throw out to the panelists is that 3D concrete printing without integrating a system of reinforcing to take tensile capacity is problematic. So how do you integrate 3D reinforcing into the printed material? My answer to that previously was, we're printing with the wrong material. We need to find a isotropic material we can print with that it's just as easy as concrete. I'm not sure that exists, but does anyone, either Mohammed or Paul, do you want to tackle, how do we integrate reinforcing into these 3D printed products?
Yeah, with great difficulty. I mean, nearly all of the case studies done so far, not all of them, but nearly all of them are effectively replacing unreinforced masonry, really, load-bearing or non-load-bearing. There have been some academic studies done on the integration of reinforcement in different ways, the introduction of fibers and so on. But I think you're right, Carl. I think at the moment, that whole paradigm just doesn't really work at the moment. I don't see how you can integrate reinforcement into the 3D printed system at this stage. You've got multiple interfaces. You can't physically place reinforcement as you go. Attempts to integrate it into the material themselves are problematic as well. There are some big issues here, which means the applications are always going to be limited at the moment, and that's a major challenge for the technology.
Yes.
To add on this, I agree with you, Paul. It's very, very difficult so far, and I've seen trials of laying a rebar within the layers, and but that is tackling one direction of the reinforcement, not the other one. So far between the layers, we don't have any reinforcement passing through, and we are just relying on the bonding between the layers to avoid delamination in future, and that is the real challenge that we still haven't got the chance as industry to overcome it. And I know there are trials going on all around the world, but as Paul said, so far it is limited, mainly because of we don't have yet the solution how to maintain the integrity between the layers of the concrete when we're printing. With welding, it's more easier. With metallic, it's more easier. Once we welded, the dot is well connected to all the surrounds. But in concrete, it's not that far yet. and reinforcement is very difficult at the moment.
Yeah, I mean, there are some ways around it that again are quite limited. So, for example, I think BAM did a bridge in the Netherlands, which was a horizontal member, but that incorporated pre-stressing to overcome the need for reinforcement by using the compressive strength of the concrete with tendons.
Yeah, if you look at that, it's modular at the end of the day. They took it as segmented, they modularized it, and they cast it under controlled environment back to modular. And they combined them all together as segmented bridge. Yes, well, that's how it works. So far, if you want to do a successful concrete 3D printing with all materials, so far, we are doing that industry now within the laboratory environment. It's difficult and it's too early to go and do it at large at site.
I'm aware of we're running out of, we're coming up on the end of our time. I'd like to maybe throw it back to each panelist to say some final thoughts. Start with George and just address any of the comments that have been made so far.
Yes, no, that was very interesting to hear all your thoughts. Just on reinforced concrete, I know some colleagues have attempted some solutions using engineered cementitious composites, which are specifically, it's not concrete, it's cement, but using some fibers and some other material inside, so that it has very good tensile capacity, not as good as the compressive, but very, very good. So, but again, the problem here is the scalability, the cost, and all these issues. Yes, no, but I don't have any other comment, because I think we covered almost all the issues. One final thought is that in some applications the cost may be offset by the optimization, let's say. So just an example, if you have the composite beams and I 3D print the shear connectors, as you see in the example, they may be 4 or 5 times more expensive than the conventional one. However, what if the design results in 5 times the strength, so I use 5 times less in total of 3D print, or 4 times or 3, so kind of offset. So that's just a thought, but this doesn't apply in all the cases, obviously.
Okay, Chris, any final comments?
Not a huge amount beyond what we've already said. I think it's a hugely promising technology. We have to be careful that we don't fall for the hype. We do need to make sure it's studied correctly and that we know what the application of it is going to be. And I think importantly, there was a comment made in the chat around regulatory side of it as well, because we're going to have to convince others that this is safe and we're able to use it and that it will replicate the performance of conventional techniques. But I think it's something that over the next couple of years is that we could see this as become the next big thing, or equally it could slink back into the shadows.
Mohammed, any final last comments?
I think every innovation, it needs a lot of time to grow and become matured enough to be let's say reliable 100%. Concrete, which is all around us, it's more than 200 years for us, and we have buildings who lived for tens of years, and we know how to handle that. 3D concrete printing and 3D printed metals are still fresh as ideas and material. We as human beings and albeit in the industry are learning from that, and we will continue with our collaboration all together, academia and the industry together. We will reach eventually, but we have to just take it step by step, not to jump. That's the recommendation.
And Paul, you want to wrap it up?
Yeah, I mean, I think we can all agree there are some significant technical challenges still in this area. There is quite a lot of hype, and I think the industry needs to look beneath the surface a little bit. I mean, the 3D printing industry is naturally keen to promote itself in the marketplace, but it really does need some proper academic research and rigor to bring it into the mainstream. We do things in a certain way in this industry for good reason, because people's lives are at stake. So we really do need some more good quality research. We need to address some of the issues around funding of research and how we fund and do innovation, and that's going to require a shift away from transactional approaches more to enterprise approaches in the industry, and hopefully that will start to bring some greater focus on the areas where 3D printing can bring value. So I look forward to seeing that.
That's a great segue back to Wendu and the Center of Excellence for Smart Construction. And Wendu, you are muted.
Yeah, happens all the time. Right. Okay. So thanks to our industry speakers and to the audience for a very interesting presentation. I just want to draw your attention to our forthcoming webinars. The first one is Women in Construction, which follows on from a webinar which we held earlier in the year. The second one we are co-hosting with WakeCap, one of our industry affiliates, and it's titled The Integrated Connection, the Future for Smart Construction Technology. And that's scheduled for the 5th of October. More details of these upcoming webinars will be communicated to you in due course. So that concludes today's program. Have a wonderful day, evening. Bye and stay safe. You may now disconnect. Thank you.
Thanks for all.
Thank you.
Thank you.
Bye all.
Thank you. Thanks. Bye-bye.